Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to discuss chemical properties. Last class I have discussed started chemical properties, but some reactions are remaining. Now that I will discuss now. Now I am going to discuss addition reaction of HBr to unsymmetrical alkenes. That is the Markovnikov rule. Alkene chemical properties. Last class I have started. I am finished these things. Addition of dihydrogen, addition of halogen, addition of hydrogen halide I have discussed. Now I am going to discuss addition of HBr to unsymmetrical alkenes. Unsymmetrical alkenes. That is, this addition is called Markovnikov rule. Markovnikov rule. This is very, very important for all examination. Now here you have to understand main things I am telling you, that suppose any alkene is there, alkene, as for example, now CH3 CH double bond CH3, that is the propene, and here one double bond is there, and with carbon number 1 double bond is there. Out of 3 carbon, that is actually it is a propene 1 in. Okay, prop 1 in you can tell, propene in a simple way. CH3 CH double bond CH2, carbon number 1 double bond is there between carbon number 1 and 2, that is called carbon 1 double bond. Now HBr reaction is going on with HBr, means propene plus HBr. Then now two possibilities there. You can get two types of product. Then here main thing is that here HBr is negatively charged and H is positively charged. When it will break, it will form H plus Br minus. Then here where it will go bromine, where it will attach the bromine, that is the main things. Okay, possibility is that carbon number 1 and carbon number 2 both it can attach, but actually what happens, two products are there, whatever possibilities there, two possibilities, it is giving two product, but one will be the main product, other will be the, you can say, side product, there that is not main product. Then main product is that bromine will attach. The rule this what you can say, Markovnikov rule. What is actually this rule? According to this rule, only bromide ion will attach. Where it will attach? Then for that this rule is there. That is a Markovnikov rule. What is this rule? The rule states that negative part of the addendum, means HBr here. HBr means bromide ion. That is the addendum, negative part. Negative part of the addendum means adding molecules. Addendum means adding molecules. Gets attached to that carbon atom which possesses lesser number of hydrogen atom. This you always remember, that negative part will attach that carbon where hydrogen is less, number of hydrogen is less. then this number of hydrogen at carbon is 2, but carbon number 2 it is only 1. Okay, that is between carbon number 1 and 2 double bond is there, that is called double bond at carbon 1. Then at carbon 1 2 hydrogen is there, and at carbon 2 1 hydrogen is there. Hence this double bond, when it will break, means one bond will break, pi bond, then bromide from HBr, bromide, that is the negative part, that will go to the carbon which has less number of hydrogen, means at carbon number 2. Then this, when carbon number, this bromide will add to the carbon number 2, then where will H go? H will go to the carbon number 1, where hydrogen is more. Correct? Then it will form CH2, CH2 and CH2, CHBr, and again CH3. This is the main product. CH3, now CH became CHBr, bromide ion attached with second carbon, and hydrogen went to the first carbon. Now it became CH3, that is called 2-bromopropane. Carbon number 2 bromine attached, that's what is called 2-bromopropane. And other possibility is that reverse case, that is not the main product, that is the side product. Okay, means now it will go in a reverse way, that at carbon number 1 bromine will go to the this bromine will go to the carbon number 1, and H will come to the carbon number 2, means reverse case. That is not the main product. This is against the Markovnikov rule. Then this product is called 1-bromopropane, means it is giving two product, 2-bromopropane and 1-bromopropane. Then 1-bromopropane is not the main product, its percentage is very less, but main product is 2-bromopropane, where carbon which has less number of hydrogen. Always remember, less number of hydrogen. Then this is called Markovnikov rule. Okay, this then this I told you, this bromine attached to the carbon number 2, means 2-bromopropane it formed. That is according to the rule. Okay, according to the Markovnikov rule. Okay, product 1, that is a 2-bromopropane is expected. In actual practice, this is the principal product, this is the main product, principal product of the reaction. This generalization of Markovnikov rule can be better understood. Now I am telling you by some mechanism how this gives a product. That mechanism I am telling you with the same reaction. Okay, means propene plus HBr. Then now here what will happen, that first in the acid medium, or you can tell when HBr will break into H plus and Br minus, then this H plus will two possibilities there to go. Either it will go at the carbon 1 or it will go to that carbon 2. Then at carbon 1, when it will go to the carbon 1, then that time this first carbon will create their positive charge, and second carbon, one time carbon 1 will create positive charge, and other time carbon 2 will get positive charge. Correct? Then here that this first product where carbon 1 is getting plus charge, that is the less stable because positive charge is there at carbon 1, then bromide ion will attach only there, then there is a less stable, and it is called primary carbocation because with this carbon only one carbon is attached, second carbon is attached with the first, only one carbon is attached, that's why called primary carbocation because at carbon positive charge is there, that's why it is called primary carbocation. This is the first possibility, it is less stable. This carbocation is primary carbocation is less stable, and secondary, now here second possibility is for secondary carbocation, that is on carbon number 2, where this carbon is attached with two carbon. This carbon, middle carbon is attached with the 2 carbon. Then that is called, it is a secondary carbocation. Secondary because 2 carbon is attached and there positive charge is there in the middle. Middle carbon is positive charge and it is attached with the 2 carbon. That's why it is called secondary carbocation. Then 2 type of carbocation is possible. Then first type, I told you, primary is less stable and secondary is more stable. And this secondary carbocation, that is the main product, and only with this carbocation bromide ion will add, hence it will give 2 type of product, that is the 1 bromopropane and 2 bromopropane. Okay, it will give 2 products. Then this I have told you. Then two bromopropane, that is the more stable. That is the secondary carbocation, that is the more stable, and its product will be more stable. Means 2 bromopropane is more stable than 1 bromopropane. 1 bromopropane. Okay. This I told you, this is according to the Markovnikov rule. This is very, very important for all examination. Medical, engineering, mains, advanced, everywhere this question is asked. One more rule is there, that is called anti-Markovnikov rule. Anti-Markovnikov rule. And this rule is also called, anti-Markovnikov rule is also called peroxide effect, and also called Kharas effect. Kharas, K-H-A-R-A-S-H, Kharas effect. Okay, three names are there: anti-Markovnikov rule, or peroxide rule, or Kharas effect. Okay. Then here what will happen, main things, here what I told you, second possibilities, that thing will happen here. Okay, but it will happen if you want more main product, that only, that is the carbon 1, then you have to use the peroxide, and this reaction was, this experiment was done by F.R. Mayo. Okay, M.S. Kharas, 2 scientists, they have performed the experiment. M.S. Kharas and F.R. Mayo, M-A-Y-O, in 1933. Okay, then this experiment has given this first these things, 1 bromopropane. Okay, then what is this peroxide effect or Kharas effect or anti-Markovnikov, that I am telling you, anti-Markovnikov rule. In the presence of peroxide, In the presence of peroxide, addition of HBr to unsymmetrical alkene like propene. Propene is unsymmetrical example of unsymmetrical alkene like propene takes place contrary to the Markov-Nikov rule, means against the opposite of Markov-Nikov rule. This happens only with HBr but not with HCl and HIE. This question is asked. Only with HBr, not with HCl and HIE. Okay, here this reaction, same reaction, but here you will use peroxide. Then which peroxide? Then here you will use 6,6H5CO whole 2 O2, benzoic peroxide, C6H5CO whole 2 O2, whole C6H5CO whole 2 O2. This is the main you can say requirement, peroxide. Then this will give 1 bromopropane. What I discussed, that things means CH3, CH2, CH2Br. Here bromide ion joined to the first carbon and it has given 1 bromopropane. Okay, and here what is the mechanism? Then here mechanism is first you should understand this peroxide, benzoyl peroxide 6,6H5CO, 2 molecules attached with the oxygen. O2 is there, peroxide, OO single bond, and 1,1 valency. Oxygen has 2 valency. Then 1,1 is joined with OO and 1,1 bond is remaining. Both oxygen has 1,1 bond remaining. Then with both oxygen, now C6H5CO will attach with both oxygen. C6H5CO will attach. Okay, then its formula will be OO, but that is called peroxide linkage, OO, and 1 oxygen valency and other oxygen valency with both CO C65 will attach. CO C6H5 will attach. Means you can write OO, between O and O single bond, and after that with both oxygen COO and C6H5. Okay, with both oxygen and you can say it is COO, C6H5 will attach. COO, C6H5 will attach with both end of oxygen. Okay, this is actually called benzoyl peroxide. Then now you know what will happen. This is the mechanism I am telling you, first step. Then now bond will break from where? From where bond will break? Then oxygen single bond is there, that bond will break, correct, and it will form 2 radical C6H5 COO and O, 2 radical, because bond is breaking between the OO single bond is there, that bond broken, hence C6H5 COO and 1 electron will be there, that is the radical. This is called 2 radical, it is forming benzoyl radical, that is called benzoyl radical. Just like HCOOH, H is going format, it is forming HCOO 1 radical. State radical same way, CH3 COO 1 electron. Like that way, here in the place of CH3, benzene group is attached, benzyl group, C6H5 is attached in the place of acetic acid CH3, formic acid H. Then now in the place of that C6H5 is attached. That is called benzoyl peroxide. Then it will form two molecule of radical, benzoyl radical. Then now what will happen? After that, this is unstable. This radical is unstable. Hence, C6H5, COO and O. This will form CO2 and it will go outside CO2. Then now what it will form? Because 2 CO2 went. Then now remaining is the C6H5 one radical. C6H5 one radical. Actually this benzoyl radical was very unstable. That's why bond has broken from C6H5. After that it was joined with COO. Then this C6H5 and C bond will break. C6H5 and C bond, from which 2 oxygen is attached, COO and C1 single bond O. Okay, that then there 6H5 and C, that bond will break and it will form 2 radical. Okay, benzene radical, that is the this thing, C6H5 phenyl radical also you can tell. Okay, phenyl radical, C6H5 1 electron. Then 2 phenyl radical it form. This is the step 1 mechanism, step 1. Then now you are knowing that this radical is formed, phenyl radical is formed 2 moles. Then now this radical will attack to the HBr. This radical will be will attack to the HBr and it will create, this HBr bond will break and H will attach to the this phenyl group and bromine will have 1 electron. Since H has 1 electron, bromine has 1 electron. Then this H electron will 1 electron will attach to the phenyl. It will form benzene and bromide radical will be created. Bromine radical will be created. 1 electron is there, bromine radical. It is very reactive. Then in third step, now it will you can say join with propene. It will join with propene. Homolysis will take place. Homolysis means what? That one bond will break and both carbon will take one electron. Then like that way this two these things it will form 2 radical. When double bond of propene will break, then each carbon will take 1 electron. Then now for bromine 2 possibilities there. Carbon 1, carbon 2, both where it can attached. Only bromine radical is there, only bromine radical. Then both carbon it can attached. Then it can attach with the second also and it can attach to the first also. When it will attach to the first carbon, okay, then it will be more stable secondary free radical, because see bromine radical attached to the first carbon. Now on second carbon 1 electron is there. That's why it is again a radical. 3 times, third time we are getting radical. Then it is a more stable secondary free radical. All are called free radical only. Then secondary free radical, it is a more stable. Okay. With the first carbon bromine has attached with first carbon. Now first carbon is more stable, anti against the Markovnikov rule. Okay, Markovnikov rule, that was the secondary was stable. Now here primary is stable. This is the difference. Primary is stable. That's why it is called anti-Markovnikov rule. Markovnikov Markovnikov. Okay, that name is a little difficult. Markovnikov. Okay, then one product I told you now which was weak, less stable. Now here Markovnikov, that is the more stable. And second possibility I told you, when it will attach to the second, bromine will attach to the second, then now first carbon will have one electron. Then in both cases free radical will be formed. In both cases free radical will be formed. Then this case it will be less stable. When bromine will go to the second, will attach to the second, it will be less stable. Okay, primary free radical, less stable primary free radical, and first was the more stable secondary free radical. Okay, secondary free radical means what was the stable here? That bromine has attached to the first. Okay, actually 3 is there. From any part where you can tell first and second, but because a double bond is broken, then from that side it is counted. Okay, then now in this Kharask effect or peroxide effect, that this bromine will attach to the more stable secondary free radical. Okay, that will be the more stable. Correct? There this I told you, there bromine was attached to the carbon which was having less number of hydrogen. But here it is not like that, reverse case. It is attaching to that carbon which has more number of hydrogen. Reverse case. Okay. Hence, this is also in the name of secondary. That is also secondary carbon. Secondary carbon is also secondary carbon. But here, bromine has attached to the carbon which has more hydrogen. More hydrogen is important here. More hydrogen, not the less hydrogen. Then more hydrogen is now becoming more stable secondary free radical. And if you will go to the less stable, then less stable, that is called less stable primary free radical, because now carbon has joined in a less stable, carbon has joined to that carbon which has less number of hydrogen against the Markovnikov rule. That's why it is called anti-Markovnikov rule. Okay, then this I have told you that it now till now it is a radical. Both are radical. Both products are radical. One is a stable product, a stable cation, and other is less stable cation. Okay, then here both are in the radical form. Hence fourth state, what will happen? Last step, last not 5 steps are there. Then now this fourth step I am talking about. HBr was there, then Br attached. Then now where Br is attached, now one carbon was the radical, was having one electron, there hydrogen will attach. And then this where more hydrogen was there bromine attached, and where carbon was having one electron, there hydrogen will attach. Hence major product will be what? CH3, CH2. CH2 was having CH, now it became CH2. This second carbon was having one electron, there hydrogen attached. Hence CH3, CH2, CH2, Br. Okay, that is the major product. major product. Okay. Then now if you will use 2 HBr, then 1 Br has been used, 1 Br will be remaining. 1 Br will be remaining, and this thing, it can again proceed. Propagation state, what you are telling, propagation state, if second HBr is coming, first HBr you understood that they are just attached to the, you can say, first carbon attached. They formed actually a stable secondary free radical. Okay. Now if second HBr you will use, then again second HBr, same situation will happen. Homolysis reaction will take place. Same reaction, first to second reaction will repeat, and third reaction same thing will happen. Now again same product, major product, it will form. Okay, and bromide radical will remain, because this thing, HBr, second time also HBr you have used, then this reaction will be repeated. Now after that what will happen, that now this fourth step, again you can say HBr is coming. Suppose propagation, this is also propagation step, then again same thing will happen. That now this things, minor product it will form. Because one product already told, main product it told, then second possibility is for minor product. Okay, then if you can say this HBr you are using, then if first time HBr using, then it will form major product, and second time, or HBr, second time is when HBr is more, then it can form minor product also. 2 times Br, 2 Br will be used, and so that is possible only when more HBr is there. Then in the product is the reaction with propene plus HBr, then it will give 2 product. One will be minor product, other will be major product. Okay, then here in anti-Markov-Nikov rule or Kharask rule or peroxide effect, that here that where hydrogen is more, that time their carbon will attach, that will be the major product. Where carbon is more and where carbon is less, that will be the minor product. Okay, then both products are possible. This is the I told you, or the Kharask effect or peroxide effect. Again more things about the secondary free radical. You got in Kharask effect secondary free radical you are getting, correct? Then actually this Kharask effect or anti-Markov-Nikov, that is based on, reaction is based on radical based reaction, but that is not the radical based. Markov-Nikov rule is not radical. Okay, that is a charged basis, but here this is the based on radical. Okay, then now I have told you these things. More things about the this secondary free radical. Secondary free radical obtained in the this reaction mechanism, that is more stable than the primary. Secondary free radical is most stable than primary. This explains the formation of 1-bromopropane as the major product. 1-bromopropane is the major product. Okay, that time 1-bromopropane was the in Markov-Nikov rule, one was the weak, unstable. Now reverse case is here. 1-bromopropane is the major product here in this reaction. It may be noted that peroxide effect is not observed in addition of HCl and HI. Always remember, it will not work with HCl and HI, peroxide effect. This may be due to the fact that HCl bond being stronger. HCl bond is stronger. That is, it requires 430.5 kilojoule per mole. HCl bond is stronger than HBr. Okay, and this is HI, and then again HCl, HI is further stronger. Okay, HBr is weaker bond actually. HBr only 363.7 kilojoule per mole. This bond energy for HBr is less. That's why easily there in peroxide effect bromide HBr is using, because that bond easily it can be broken. Only 363.7 kilojoule per mole, but HCl is 430.5 kilojoule per mole. That's why it is not cleaved by the free radical mechanism. Okay, whereas the HI bond is weaker, very weak. Whereas HI bond is weaker, and iodine free radicals combine to form iodine molecule instead of adding to the double bond. Here important things you have to understand. HI is weak. Its energy bond is weak than HBr. HCl is strong. Okay, HBr is weak, and HI is again further weak. HI, then you can ask HBr bond is breaking. Then okay, this addition reaction is going in both cases. Markov-Nikov rule. HBr only both you are using. Why not HI? HI is further weaker. Then why not HI? HCl is okay. HCl is stronger. HI is only bond is 296 kilojoule, 296.8 kilojoule per mole. Then why not with HI? This Markov-Nikov rule or anti-Markov-Nikov. Why? Then its main reason is that HI is weak, very weak, 296.8 kilojoule per mole. Then what will happen? This bond breaks, that is okay. Radical forms, that is also I radical it forms. But what happens? This I radical will be very reactive, and if more you can say HI is there, then more I radical will be formed, then they themselves will join. I radical will join, and it will form I2 molecule. That's why this HI will not work here in peroxide effect. HI is not used, it will not work, because I radicals are very reactive, and they will form I2 molecule, I2. This will quickly they will combine to form iodine molecule instead of adding to the double bond. This I have told you about the these things, anti-Markov-Nikov rule, peroxide rule, or Kharask effect. Now I am telling you these things. Next reaction, that is the addition of sulfuric acid. Then it reacts this ethylene or alkene reacts with sulfuric acid, first with cold concentrated sulfuric acid. Cold condition, you remember, cold concentrated sulfuric acid adds to alkene in accordance with the Markov-Nikov rule to form alkyl hydrogen sulfate by electrophilic addition reaction. here just like Br minus, here H plus and HSO4 minus, not this things, it breaks H2SO4, it breaks into two parts. Okay, SO3 is the one part, SO3OH is H2SO4. Then how will you write here? Then you can write it as a H, SO3OH. You can write it very easily. H2SO4, then one H, that bond will break. Then what is remaining? SO3OH will remain, SO3, H2SO4. Okay, 4 oxygen is there. Then SO3OH, then total 4 oxygen and H is there. One hydrogen that is going to be broken, H and S, that bond will break. Okay, then here it will form actually CH3, means where this negative part will attach, then negative part will attach. Now only 2 carbons are there. You have to, I am taking example of ethylene, then any carbon it can attach. Okay, and H will be less there. H has gone, double bond broken into the single bond. Double bond means pi bond broken, then H has gone to that hydrogen where that carbon where was more hydrogen, means with CH2. Okay, it formed CH3. Had one hydrogen, when bond broken, one electron was with hydrogen and one electron was with oxygen. Okay, then this hydrogen, one hydrogen joined with one carbon, very simple reaction, and other radical, one radical, hydrogen radical joined with the first carbon, and remaining radical, that is the SO3OH. O, after removing H, what will remain? O will remain. O radical, OSO3OH. That you can say OSO3OH, that will join with the first carbon. Okay, then it will form ethyl hydrogen sulfate. This product is called ethyl hydrogen sulfate, or simply you can tell C2H5HSO3. HSO3, okay, then C65H, not HSO3, HSO4, C6H5HSO4, means very simple way, H2SO4 was there, one H gone, then HSO4 is remaining. Then this HSO4 is a negative part and H is a positive part. Or you can tell both will have one electron. H has 1 electron and HSO4 has 1 electron. Then one H will join with the one carbon and other HSO4 is joined with the other carbon. Very simple things. Then complete H2SO4 is present in that molecule. So only thing is that one hydrogen joined with first carbon and remaining is joined with second carbon, and that is called hydrogen sulfate. Ethyl hydrogen sulfate, because now CH2 CH3 became CH3 because one hydrogen added with CH2, it became CH3, and now with the second carbon remaining parts of H2SO4 attached, then it becomes CH3 CH2 OSO3OH, and in a simple way you can write C2H5HSO4. But here bond will make between oxygen and carbon, that you don't forget. Bond will be formed between oxygen and carbon. Okay, OSO3 OH. OH is separate, you can keep joined OSO3. Okay, then this is called ethyl hydrogen sulfate. Now again I am telling you, same reaction. If propene is there, then what will happen? If propene is there, then again propene plus H2SO4, cold, concentrated H2SO4, cold. Then here same situation will happen, only methyl group is attached. One from the this ethylene, one hydrogen gone and one methyl group is attached. Only chain became long, but reaction will be the same. With second carbon, H will come and remaining part of the H2SO4 will attach to the first. Okay, double bond will become single bond. Then you will get here now already CH3 added, that will be as it is, and only CH became, CH2 was there, CH2 was there. Then now here you have to understand one thing. Then here this things, hydrogen sulfate, where it will go? Hydrogen sulfate, where it will go? Then here it will go according to the Markov-Nikov rule. Because here if you will think, one time you think as a charge by also, then if H is going as a H plus, then remaining part will be the negative, that you can treat as a bromide ion, Markov-Nikov rule. Then it should go to that carbon which has less hydrogen, that's why it will attach to the, you can say, second carbon. When methyl group is attached, that will become first and center, and then again one carbon. Then double bond is between the second and third. Then second carbon, one hydrogen is there, only one hydrogen, and third carbon, two hydrogen is there, and first carbon, three hydrogen. Then where will go negative part? Then it will go to the second, where hydrogen is less. Then now that remaining part of the H2SO4 will join with second, correct? And this hydrogen will go to the third part, because when bond breaks, then neighboring carbon only they will it will affect to the neighboring. Then neighboring carbon, it will attach the H. If this part, remaining part is negative, then H plus is positive, then it will go to the first carbon. Okay, and methyl group is as it is, no, nothing is to do with that. Then now it became propyl hydrogen sulfate. Then this I have told about the addition of sulfuric acid. Means H2SO4 is going to be absorbed, you can say, not absorbed we can tell, but going to be used only completely, nothing is coming outside. One H to the that carbon where hydrogen is less. Okay, just it follows the Markov-Nikov rule. Now next reaction I am telling you, addition of water. Then here in the presence of, you can tell, in the presence of few drops of concentrated sulfuric acid, alkene react with water to form alcohols. This is a very, very important reaction. Ethylene forms alcohol in presence of, ethylene reacts with water in presence of few drops of concentrated sulfuric acid. Okay, and this also happens according to the Markov-Nikov rule. Means here what will happen, that example I am telling you, 2-methyl propene, you can take example, 2-methyl propene, means at carbon number 2 methyl group is attached. Propene you have written, first carbon double bond is there. Okay, then methyl group is attached with the second carbon, means middle, then it will be 2-methyl propene. And now this H2 is going to be added in the presence of acid, concentrated H2SO4. Then what will happen? Here that with carbon number 2 now 2 methyl group is attached already, propene, that one straight line chain, one methyl was there, with second methyl group is attached. Then now from the second carbon 2 methyl group you can tell it is attached. And here what will happen, that this CH2 group means second and third double bond is there, propylene you are talking about, in that methyl group is attached with second carbon. That's why second carbon you can tell 2 methyl group is attached. Then now H2 is coming. H2 is 2 part, OH part negative part, H is positive part. Then according to the Markov-Nikov rule, OH part will go to that carbon which has less number of hydrogen. Then carbon number 2 has no hydrogen at all. No hydrogen at all. Then this OH will go to that carbon only, means carbon number 2. Then now with carbon number 2, 3 groups are attached. 2 methyl group and 1 OH group. And where H will go? Then H will go to the other carbon. Double bond was there, then that with you can say that middle carbon is the second carbon. Then there no hydrogen is there. Then when bond will break, then hydrogen will come, OH will come, negative part will add to that carbon which has no hydrogen, and hydrogen will go to the third carbon which was having CH2. C and double bond CH2 was there, that CH2, in that carbon hydrogen will go. Now that carbon became CH3. Then now it became, you can say, with the central carbon, that 3 methyl group is attached and 1 OH group is attached. That's why it is called 3-methyl propane 2-ol. 3-methyl propane 2-ol. 3-methyl got automatically because CH2 became CH3. CH2 was all 3, 2 CH3 was already attached. Extra one OH is also attached. Means with the central carbon, middle carbon, 3 CH3 is now there and 1 OH. Then long chain you have to consider. Then in that case it will come 2-methyl propane 2-ol, because OH group is attached with the second only. 2-methyl propane 2-ol. Now next reaction I am telling you oxidation of alkene. Alkene on reaction with a cold dilute aqueous solution of potassium permanganate KMnO4, that is called Bayer reagent. Potassium permanganate solution, dilute aqueous solution, means potassium permanganate is dissolved in water. Potassium permanganate is a solid. You will dissolve in water, then it will become liquid. The dilute aqueous solution potassium permanganate, that is called Bayer's reagent. Bayer's, Baeeyers, Bayer's reagent. Then alkene, any oxidizing agent, it will supply oxygen. Okay, remember. Okay, then oxidation you are doing, oxidation of alkene. Then alkene will oxidize. Then means oxygen is going to be added. Then what it will form? Then after this alkene plus KMnO4 solution, it will produce vicinal glycol, ethylene glycol. 2 OH group will attach continuously with 2 carbon. Okay, CH2 plus aqueous solution is there, then H2O plus O. O only you are writing because potassium permanganate will release oxygen atom. The main reaction is with oxygen atom. Hence you can write CH2 double bond CH2 plus H2O plus O. O is coming from KMnO4. Then there you should write dilute KMnO4. But reaction will take place CH2 double bond CH2 means ethylene plus H2O plus O, 3 product, and it will give, now because H2O is there and O is also there, then it will form H2O2. H2O2 means 2 OH, OH and OH. Then this OH and OH bond will break. Then 2 OH group it will form. H2O plus oxygen. It will form H2O2, peroxide. Then OO is a single bond. OH, OH. And between the O, single bond is there. That bond will break. Then OH and OH, 2 radical it will form. Then this 2 OH, it will join with this 2 carbon. Double bond is there, ethylene. There one bond will break. That is the I bond will break, and one radical each carbon will take, and one red electron is with this OH. Then both OH will join with both carbon. Then it will form CH2 already it was there. CH2OH, CH2OH. CH2 already was there after breaking one bond. Then one electron of the first carbon, and other electron, one more electron with second carbon. Then both will form a bond with OH. 2 OH is there. Both OH will go to the first and second carbon. It will form glycol. That is also called ethylene glycol, or you can tell ethane 1,2 diol. 2 alcohol group is there, also called ethylene glycol, or simply glycol, or IUPAC name is ethane 1,2 diol. Okay. Now second example of oxidation, same oxidation second. Then here again that example now given for the ethylene, only 2 carbon was there. Now propene. Then now chain became long, 1 methyl, in the place of 1 hydrogen 1 methyl group came. Then now CH2 became CH and 1 methyl group attached. Then second and third double bond is there, just like a previous. Then second and third is double bond, but second carbon has only 1 hydrogen. Then same reaction. Then again they will form glycol. Again it will form 2 OH group will attach with the second and third carbon, and double bond became single bond. Then now it became CHOH, again with third carbon CH2OH. Nothing happened when the with second and third carbon OH is attached, according to the what I have discussed earlier. Okay. Then both OH, double bond became single bond, 1 electron. Both carbon got 1 electron. Both OH have 1 electron. And so it will form OH bond. Now compound is propane dash 1,2 diol. Propane dash 1,2 diol. Same product, only name became propane. That time it was ethane. Now it became propane. That time it was ethane 1,2 diol. Now here propane 1,2 diol. Same things. Okay. Now this I told you with a aqueous potassium permanganate. Reaction with aqueous means with water. Okay, with water. This was the dilute aqueous solution. Condition is there. This you got glycol with aqueous solution of KMnO4, beer strain. But now if you have acidic KMnO4, then acidic potassium permanganate means now KMnO4 is dissolved in acid. It can dissolve in water also, acid also. Then now when it is dissolved in acid, then it is called acidic potassium permanganate or acidic potassium dichromate. Both are oxidizing agent. Potassium permanganate is also oxidizing agent, and potassium dichromate is also oxidizing agent. This is a stronger, potassium dichromate is stronger than potassium permanganate. If it will react with alkene, then both will supply oxygen. Both will supply oxygen, any one, either permanganate or dichromate, K2Cr2O7. Okay, it is potassium dichromate, K2Cr2O7. Then in the presence of any one oxidation, this alkene will oxidize. Okay, and what will it form? It will form a ketone. Ketone means COO group it will create, COO, that is the ketonic group. It is also called carboxyl group, CO group. When both sides CH3, CH is there, then it is called acetone. But this that time CO will be called ketonic group. Okay. Then this CH3, CO is in the middle, one side CH3, other side CH3. This is called acetone. Otherwise, other group is attached, like ethyl group is attached both sides. Or one side ethyl group, other side methyl group. Then that time it will be called ketone. Acetone will be called only when its methyl group is attached both sides. Then acetone. Otherwise, any other things are attached, then that time it is called ketone. Only CO, if CO group is there, only CO in the middle, one side ethyl, other side methyl, or both side ethyl. Then ketone. If both side methyl, CH3, CH3, that time acetone. Then alkene converts to ketone in presence of acidic potassium permanganate or dichromate, potassium dichromate. Okay. And one thing here I want to tell you, that when aqueous solution of potassium dichromate, that is a bare reagent, I told you, that it will, if reaction will take place, then this KMNO4, it is a colorful, it is just like a purple color. KMNO4 is a purple color. That color will go. When it will react with alkene, KMNO4, then it is a purple color, KMNO4, that color will go. Okay, decolorization of, that is called decolorization of KMNO4 solution is used as a test for unsaturation. This bare strain reagent is also, that is the KMNO4 will become colorless, decolorized, color will change, decolorization of KMNO4, that is actually used as a unsaturation, because that unsaturation, decolorization is telling that KMNO4 has supplied oxygen and it was used, because oxygen has gone from the KMNO4, that's why its color will change. Okay, now I was talking about the acidic potassium permanganate. Then it will form, alkene will convert to ketone, and acids, depending upon the nature of the alkene, it will form ketone as well as acid, and that will depends upon the nature of alkene and the experimental condition. Then two product it is forming, ketone it will form and acid also it will form. When KMNO4, acidic KMNO4 you are using, then that time that 2-methyl propene means with carbon number 2, 2-methyl group will be attached. Okay, then carbon second and third double bond is there, because it is a propene, only in carbon number 2 methyl group is attached. Then here acidic KMNO4 you are using, then that carbon actually what will happen, that will convert, second carbon will convert to CO, that both bond will break, and C carbon will take one oxygen, and both bond broken, but it will make a double bond with oxygen. Oxygen always will make a double bond, only in rare cases in peroxide it makes single bond. Then it will form with carbon number 2, already carbon number 2 CH3 group is attached, propane was there. Then now one oxygen came. Then CH with second carbon 2 methyl and CO. This CO group is called ketone. This CO group is called now here ketone. And because total 3 carbon is there, CH3 whole 2 and C, total 3 carbon, that is the propane, and with carbon number 2 oxygen is attached, that is called propane 2-one. Propane 2-one, that is the ketone. Total 3 carbon became long chain, and with carbon number 2 oxygen is attached, COO, that is called propane 2-one. And what are the 2 other products? Then because bond has broken, then that because oxygen was, too much oxygen was there, then one oxygen came with the carbon, and other oxygen went with this another carbon and hydrogen, both other carbon CH2 was there, that now part Y part broken, that carbon is taken and converted into carbon dioxide CO2, and hydrogen also converted into H2O, means complete, they taken more oxygen. That's why powerful potassium dichromate is powerful oxidizing agent. It has given it has given 2, 3, 4 oxygen, it has given 4 oxygen, one with this CO, that time CO2, 2 oxygen there, and hydrogen H2O, hydrogen form H2O, then see total 4 oxygen. That's why this is used, either KMnO4 or potassium dichromate is used, because it can supply more oxygen. Then it gives 2 products, one ketone, one carbon dioxide, and H2O, water. This is a very, very important reaction. Then here ketone name is propane 2-one, propane 2-one. Okay, and when KMnO4, acidic KMnO4 you will use, then suppose now this time you have taken butane, suppose you have taken butene, double bond, then 4 carbon will be there. Then first, second and third, suppose second and third, between that double bond is there, butene, total carbon is 4, but middle 2 has double bond. Then from the both side actually they are in equal position, double bond. Then but 2 in, then here again only chain became long, and here it will form because this things 4 carbon is there, 4 carbon is there, and hydrogen how much is there? Then 2, 3, 4, 3, 4, 5, 8, 8 hydrogen is there, 4, 5, 8, CH3, CH double bond CH, again CH3, first and last CH3 is there, then 6 plus 2, 8 hydrogen is there and 4 carbon is there. Then what will happen? 8 hydrogen and 4 carbon. Then here it will form acetic acid, CH3 COOH, CH3 COOH, 2 molecules it will form, 2 molecules. Then CH3, 1 carbon, CH3 COOH, that 1 carbon, then 2 carbon, then 2 molecule it is forming. It means 4 hydrogen used up, 4 hydrogen used up. And how many oxygen is there? 8 hydrogen was there, 8 hydrogen. Now you can see total 8 hydrogen, CH3 3 hydrogen and COOH 1 hydrogen, H, then 4 hydrogen, then 2 molecules is formed. Then now carbon is balanced, hydrogen is balanced. Then now extra things what came? Then extra thing is oxygen, extra thing is oxygen, that is the double O, CH3 COOH, 2 molecules means 4 oxygen. Then who have supplied this 4 oxygen? Then it is supplied by KMnO4. In both this reaction, KMnO4 and potassium dichromate both can be used. Then now this acetic acid is also called ethanoic acid. Acetic acid is also called ethanoic acid because 2 carbon is there, ethane. That's why ethanoic acid according to the IUPAC name. Then now I have discussed these things, chemical reaction, but it is not fully finished. More reactions are there. Chemical reaction, this ethene has more chemical reaction. Then some are again remaining. Then whatever is remaining, now I will discuss next class, and I will start ethyne also. Ethyne triple bond. Correct? Thank you.